Hello and welcome back to Introduction to Astronomy. Today we're going to be doing the lab on rocks and minerals. So if you would go to Canvas and then go to Modules and then go to Labs, you're going to be opening up the Unit 2 lab, which is on the solar system. And then once you've opened up that Excel document, then down at the bottom you're going to click on the tab that says 11 Rocks and Minerals. Okay, so you're going to have that one open. You're going to want to find the document, which is also going to be under this under Labs, and it is going to be entitled the Astronomy Collection Contents with Pictures. So when you open that document up, you're going to see a whole bunch of images of rocks and then what their numbers are. And then that's going to correspond to the box of minerals and rocks that we have here at OTC. It's a big green box. Now, if you don't have the box at home with you, then you're just going to have to use the pictures that are given, and then also you could look these samples up on the internet and find additional pictures of them. If you do have the box is available over in the Science Suite here at the Springfield campus of OTC. And there is also another green box that is available to you over at the LRC, which is the library here at the Springfield campus of OTC. So I would prefer if you actually have real samples of rocks and minerals to look at, but if you don't, then you can use this Astronomy Collection Contents with Pictures to look at what each of these samples looks like. And then you can also, for additional information, you could go to the internet and find this information. A third document that you're going to need to have open is go to the lecture materials and then open up the PowerPoint that says Lesson 10 on Planetary Geology. So we may be referring as well to that document. Okay, so let's go to the lab. So you're going to do the pre-lab questions, but you might want to just go through the lab with me today, and then afterwards come back and then do the pre-lab questions. So I'm going to skip the pre-lab. I'm going to go down to the actual lab itself. So it says procedure, and then part 1 is the mineral forming elements. So we're going to start with elements. We're going to take those elements, put them together to make minerals, and then we're going to take the minerals and put them together to make rocks. So starting off with part 1, it says that outer space consists of about 99% gas. And of that 99%, about 75% of it's hydrogen and about 24% of it's helium. And then outer space also has 1% dust. And that 1% dust is everything else. So everything in the periodic table originally was floating around in outer space as dust. When the Earth first formed, any hydrogen or helium immediately escaped because it was so light. So that means that all the Earth was left over with was that dust. So the Earth was composed of that dust. And it was left with a composition of about 35% iron, 30% oxygen, 15% silicon, and then 13% magnesium. So, and then a smattering of the other elements. But if you look around you, everything in your room or wherever you're at is composed of the elements that was inside that dust that was floating around. Um, if you look, however, at the composition of the Earth's crust, you notice that most of the iron is missing. So if you look at the percentage of iron inside the Earth's crust, the crust being the upper layer of the Earth, you notice it's greatly diminished as compared to the amount of iron that's inside the Earth. So your first question is, where did that iron go? Okay, iron is very dense, so that's your clue. So explain to me, where is that iron today? Okay, what the crust is made of is mostly oxygen and silicon. These elements chemically combine to make the silicate minerals, which we're going to look at here in just a moment. And silicate minerals make up 90% of all of the minerals that are inside the Earth. Okay, let's go down to part 2. So now that we know what we're working with is mainly going to be oxygen and silicon with a smattering of other elements, we're now going to put those together to make minerals. So in your green box, minerals are going to be samples 1 through 20. So you might also want to refer to that Microsoft Excel spreadsheet that has all of the pictures of the minerals and the numbers that goes with them. So we're going to be looking at samples 1 through 20. So I encourage you, if you've got the green box of rocks and minerals, open that and take a look at it. If you don't, then just look at the Microsoft Excel sheet. Minerals are the building blocks of rocks. For example, in the rock granite, so granite is going to be sample 22. So sample 22, okay, that's granite. And you can see that granite is kind of speckly. And you'll notice that there are basically 3 kinds of speckles that are in granite. So you got white speckles, and then you also got clear speckles, and then you got pink ones. And then there's also some black ones. So the clear ones are the quartz. So that's going to be sample number 1. So this one right here, that's quartz. And then the dark colored speckles are going to be plagioclase and orthoclase. So this one is plagioclase, so that's going to be sample number 2, and then sample number 3 is going to be the orthoclase. So those are your and then also there is some biotite and muscovite in it. So this here, that's going to be biotite, and then this one here is, the clear one, this one right here, that's going to be your muscovite. So those are your major minerals that are going to be inside of granite. Alright, so I'm going to stop this video here, and then when we come back, we're going to talk about properties of minerals. How can minerals be identified?